Thank you and good evening, everyone. Today I will be speaking about Windows Event Log Fast Forensic Timeline Generator and threat hunting tool called Hayabusa. Let's get started. Here is the agenda for this presentation. My name is Fukusuke Takahashi, and I worked for NTT Data. At this conference, I am a co-author of IRC Dream. I'm also a member of Yamato Security, a security group based in Japan. Hayabusa is a Windows Event Log Fast Forensic Timeline Generator and threat hunting tool created by the Yamato Security Group. The project members are listed up here, and it's me. Thank you. Hayabusa has many attractive features, which I will briefly explain on this slide. It's open source and free to use. It is developed in Rust and is very fast. It can process huge event logs files in a short time. Hayabusa can create different timeline in either CSV or JSON format, so it is easy to analyze. Nearly 4,000 of the latest Sigma rules are built in and updated almost daily. The Sigma community is very highly active, and also almost all of the emerging threats that comes out can be detected with Sigma rules, often before commercial vendors can write rules for them. Event logs are on all Windows machines, and they are the core artifact to Windows investigations. However, there are some issues with event log analysis. Windows event log file is binary, so tough to read and tough to process. Too many noisy logs are tough to investigate quickly. These issues bother us. Hayabusa solves these problems. If you use Hayabusa, investigating event logs will surely become fun. The rest of the slide introduces Hayabusa's main commands. The first is a search command. This command can grab EVTX files with arbitrary keywords and regular expressions. For example, if Mimikatz is specified, event logs containing the keyword Mimikatz will be extracted as shown in this screen capture. Also, the result can be saved in CSV format. The second is the pivot keyword list command. This command will automatically extract IOC for you. Simply run the pivot keyword list command to automatically extract IOCs such as usernames, IP addresses, and command lines from the event log. The third is JSON timeline command. Executing this command outputs the result of scanning about 4,000 built-in Sigma rules in JSON. JSON is a format that is easy to process, so using JQ commands allows you to perform more detailed analysis in a short time. For example, you can display the date and time with the most Sigma rules detection with run JQ command. Hayabusa's GitHub repository has published a guide for analyzing Windows event logs with the JQ command, so please refer to it. The first is the CSV timeline command, similar in functionality to the JSON timeline command, but this command creates a timeline in CSV format. There are many other useful commands as well. I would be happy if you could try using it. Hayabusa is still under active development, and we will release a new major version about a month. We announce a new release and other information on Twitter. If you are interested, please check Security Yamato. Thank you for listening. Thank you.
Thank you very much. Oh, sorry. I know you need your laptop, I guess. It's your laptop, right? Could I get our next lightning talk up here for the attack flow talk? You almost had time for one question. Like, there's a bonus if you squeeze in a question, I think. Come on up. Let's give a round of applause for our AV guys. They're staying late to help us out. Thank you so much. Hey, are you good with HDMI? Or do you need an... All right. Let me know when you're ready.
All right, I think I'm ready. Hello, everyone. My name is Mark. Where am I looking for the time?
All right, you go.
Okay. Hi, I'm from the Center for Threat Informed Defense. We're a part of MITRE. And, okay, you can see this? So I want to talk to you real quickly about attack flow. The idea behind attack flow is... The key idea behind attack flow is we typically think about adversary behaviors in isolation. So for example, you can see here public reporting about a Tesla breach. And what we might do is we might go through this, we might identify the specific behaviors we saw. You might even use a common lexicon like attack to identify those behaviors. But then what do you do with that list? One idea here is you could take the attack matrix and you could shade in all the techniques you saw. You might even superimpose your detective controls, your mitigating controls, and try to see where you have overlaps and where you don't. But in practice, this is actually really difficult to do because a lot of the behaviors we see are not obviously malicious. So here's a quick example with 4 behaviors: ingress tool transfer, base64 encoded files, PowerShell execution, process dumping, LSAS memory. Out of the 4 of those, one of them is like extremely suspicious. The other 3 happen a billion times a day and are not malicious. So if you look at these in isolation, it's not clear how you detect them. How do you detect ingress tool transfer? That's kind of a big unsolved problem in the industry. But if you look at the right side, we've taken those same techniques and put them into a sequence. And so now we can say, well, we saw someone download a script. That alone isn't that suspicious. But if that script was base64 encoded, okay, that's a little bit sketchier. If that script was then executed in PowerShell, that's really starting to raise an alarm. And then finally, if that script process dumps LSAS, then probably like all the alarm bells should be going off at that point, right? So I found like giving a 5-minute talk is harder than giving a 30-minute talk because what do you focus on? I want to just quickly jump over and show you what attack flow looks like. This is an open source project. It's free to use. If you go to our website, just Google attack flow, or better yet, DuckDuckGo. We have higher search results there. If you come to the examples page, you can quickly open up. We've got a bunch of sample flows already built based on public intelligence.
Your slides right now.
Oh, I'm sorry. How do I... There it is. Oh boy. I feel really bad because this is not my laptop. Here we go. This is the tab I'm looking for. So this is the attack flow builder. What you see here is that same Tesla breach, but this is translated into the attack flow format. These blue boxes indicate the various adversary behaviors that were observed. There's a lot of details you can add there. And as you zoom out, you can start to kind of see the different paths of the flow, right? One flow is setting up the infrastructure. One flow is the actual breach. We have a couple additional objects you can see in green and red. These are kind of like the logic of the flow. It allows you to do things like Boolean tests or combining multiple paths together. And then on the sides, you can see these gray boxes. These are Stix objects. You can take any object in the Stix data model and put that into your attack flow. And in fact, the entire attack flow is a Stix bundle. So you can export it, and it's compatible with any Stix tooling. That's all I got. Thank you.
You know what? We got time for one very short question. Round it out, or we'll have our next speaker. All right, so can we Thank you very much. Can we get our next speaker up here for the microemulation plans talk, please? Hey, Mike. No slides? No. Good man.
Hey guys, my name is Mike Cunningham. I work at MITRE Ingenuity, and more specifically, the Center for Threat Informed Defense. Before that, I worked on attack, and I was also on the attack evaluations team. So I've been doing red team and adversary emulation for quite a while now. And one thing that we started to notice very early on is that adversary emulation plans are very complex and difficult to execute. And also, they're pretty invasive. Some of the last plans we made for Wizard Spider and Carbonac involved launching actual ransomware in a network. And so convincing your stakeholders to use those plans can be very difficult and time-consuming and expensive. And so we wanted to create a solution to allow people to perform adversary emulation on a much smaller scale, a more focused scale, and a way that was defanged and completely safe to use. So we made a project called Microemulation Plans that focuses on very specific techniques, typically 2 to 3 in quick succession. They're packaged up in executables. They can be launched in any environment. There's no dependencies, no network dependencies or software dependencies. And these micro plans allow you to validate your defenses, your logging, your detections really easily. Some of the example plans we have are DLL hijacking, process injection, log clearing, data exfiltration. And we have about 12 different plans that people can use. So if you implement a new detection that you think is going to detect some adversary behavior, you can quickly fire off these executables in a production environment to verify that those work. Our project is open source. If you Google microemulation plans, it should come up. It's part of the larger adversary emulation library that we maintain. And if anyone is interested, we have some cards with the QR code I can hand out and take you guys right to the resource. And that is my lightning talk. Thank you.
You got time for 2 questions, maybe 3. Anybody got a question for Mike? All right.
Oh, easy.
Well, seeing none, Mr. Kaplan,
Thank you.
thank you very much.
Okay, so I took away from the previous presenter that without slides, it's just way faster and actually more to the point, so apologies for the slides. I've been lucky to be able to play around with deep learning and LLMs for the last months, and with deep learning since 2020, roughly, when the pandemic started. My talk is about like how you can use that even locally. There are some ways to do that. If you just want to take away the really short summary, the TLDR, it's not magic. All of that is not magic. It's just statistics. It will, break the idea of having a black box where you put in stuff and it magically solves your problems. It's not going to do that, but you can run it locally. And yes, you can do a lot, and especially with CTI, where you have unstructured text. I think it will get better over time, especially the local ones, the local LLMs, open source ones. And I would be very interested in talking with you if you're into that field. Tomorrow we have a BOF at 12 noon. That's basically my lightning talk. It's like a shout out to you. Please join that in case you're interested, if you want to learn from others, or if you have something to share. I think we have a few interesting use cases which still need to be discovered, and therefore I would like to do that together with you. That's basically the short version of my lightning talk. Since I have a few minutes, thanks to you, I can go into details. I think CTI reports are a good example for natural language processing. Most of the time, they're still unstructured, PDFs, blog posts, etc. So often what we do is like we take that and we select text and copy and paste into ticket systems, into OpenCTI, whatever, and that's a manual task. Ideally, I would like to have something inspired by Patrick, because I see him here, that would convert that to sticks in a structured way, because there's way too much unstructured comment fields, where it would be much better to have structured data. That's a typical NLP task, information extraction. Previous work is done by, for example, Bosch, by Patrick. He had a really good talk in Berlin, which inspired me. Thank you very much. Also, the Maitre folks have been doing great work with Tram and a couple of others. But so far, compared to what you see now when you are on Twitter, like AI topics or so on, our field is underrepresented here. There's not really a good LLM specifically for cybersecurity. So I thought, if there's none, how about if I just try GPT 3.5 and 4? And, okay, my slides are really, that don't work here. Anyway, I made a small web front end where you can query GPT 3 or 4 to have a task like summarize this. You have a prompt before, and then you have the text here. And yes, I said only submit TLP clear data to that because it's some web service out there. Yeah, and the source code is here. You can copy that. Short answers, it works. If the prompt is specific enough, then you can actually really extract from the text the TTPs, the IOCs. The IOCs usually you could do with regular expressions, but TTPs and relationships between different entities, like threat actor does that, uses these tools, like the typical sticks graph representation. You can get that from via just a large language model, which is astounding. I didn't know that. It wasn't trained for that. But it leaks. It leaks to OpenAI. So how about running that locally? Yes, there are open source models that you can use, mostly the Llama on top of Llama. There is a data set where you can fine-tune these open source models like oracle.eu. And there's a mechanism called LoRA, which allows you to train that in a matter of maybe 15 or 20 minutes. So you have a large data set like Oracle, 15,000 reports, a couple of thousand threat actors, and take that text, unstructured text, train your LLM with that LoRA approach, which is basically a matrix, low-rank matrix. And here is the link with the tool, how to do it. And I think I'm finished now, sort of, right? Yeah. And tomorrow is the BOF. Thank you.
Thank you so much. The Riskenkoff next. Pretty good so far. Thanks, Aaron. Don't forget to introduce. Let me know when you're ready to start.
Yep.
But we're not seeing your slides.
Hello, everyone. I'm Kiyoshi Ogasawara. I come from Japan. Thank you. Thank you. Today, I'm happy to have an opportunity to give a writing talk here. So first, let me introduce myself. My name is Kiyoshi Ogasawara again. I work as a software engineer at Cyber Agent Company in Japan. Currently, I'm mainly involved in the development of cloud security tools. Today, I'd like to introduce Riscan, one of the tools we have developed and released as open source software. So I have 3 topics. First, introduction to Riscan. Second, how to use it. And finally, its features and cost. So first of all, I'd like to give you an overview of what Riscan is. The name Riscan is made up of 2 words, risk and can. Risk means security risk, and can has meaning of detection or finding in Japanese. So Riscan is similar to CSPM. CSPM means Cloud Security Posture Management. By using Riscan, you can automate some security operations of correcting, evaluating, and notifying vulnerabilities or threat information in the system environment on cloud. So next, let's move on to the installation. I'd like to explain how to start Riscan and how to use it easily. For example, on a Mac PC, launching Riscan is just 3 steps. And next, you can register your cloud information, so you want to scan. So Riscan has scanning features for various cloud environments. It's called data source. For example, it includes AWS, GCP, GitHub, WordPress, and more. Once the scanning of various data sources is completed, you can see the security findings. This is finding detail. It displays the description of current state or the nature of the threat and recommended actions. Additionally, by clicking ChatGPT button, the content will be summarized for you. This can be helpful for non-security specialists. Next, let's move on to the features. Compared to other CSPM tools, Riscan has some features. First, wide coverage. Second, detection accuracy. And finally, continuously improved based on experience in actual cloud incident response. Riscan can be started at a low cost, but I'm sorry, I have no time, so I'll skip this page. And in what cases has Riscan been useful? So I'd like to share some case studies, but I'll skip this page as well. Finally, I'd like to summarize the key points of today's presentation. Riscan is a cloud security tool. It's an OSS, and it is cheap but powerful tool. So if you are interested, please feel free to try it out. Here is the documentation and other resources. So also feel free to access these links. With that, I'll conclude my presentation. Thank you for your attention.
And we actually have time for a question or two if you want. Anybody? Well, let's give him another round of applause because that was awesome talk. Come on up, Masato. For those of you who are new to our community, let me explain something. I might give Masato a little bit of extra time, and I hope you don't mind. Those of you who've been around for a while know why. All right? So, without further ado, the one, the only. Please introduce yourself and let me know when you're ready to start. I like it like that.
It's okay? Hi.
I just have to ask one point of clarification. It's TLP Amber. That means please don't take any pictures of the slides, right? TLP Amber, no pictures of the slides, right?
Yeah.
So don't take pictures of the slides. Thank you.
So this is Masato, and also I show the sticker injection attack 2023 initial report. So sticker injection attack and the SIA began spreading on June 4, 2023, triggered by its logic to exit the 4-year sleep mode. SIA combined sophisticated social engineering attack with sticker injection attack. But the objective of the campaign SIA, official name of sticker injection attack, is talking to all attendees, and it was initiated in 2005. So SIA aim to provide a common topic for all attendees, including those attending for the first time or multiple times to enjoy the first conference together. Goal is to establish a trusted user relationship for the global CSAT activity through the conversation. Overview of campaign or SIA. SIA consists of 3 steps: active scan, conversation interrupt, and sticker injection. This is the attack flow. Describe a sequence of campaign behaviors. I studied the MITRE attack flow first day, June 4th. At first, threat actor. Me and 11 proxies, but it is autonomous agent. Next, action. At 3 steps, T1595, 0814, and 1491. Next is the vulnerability. CVE 2023, the first, titled Name Batch Defacement Vulnerability, Impact the Name Batch Defacement and Conversation Interrupt. Identifier, CPE, CWE, and also CVSS 3.1 and 4.0. 4.0 is the AT, the attack requirements, and the VC is the vulnerability component, SC is sophisticated component. I described the details. And target is the VC, vulnerability system. Target for coverage is the sophisticated system. Attacker is here. So VC is confidential impact, no. Integrity impact, low. But defacement and availability conversation interrupt. Sophisticated, no, low. Because availability impact is conversation interrupt, that's only. Last indicator, bot deployment. Happy code is signal colors, green 3, yellow 3, and red 6. Our batch defacement indicator, over 1,500 stickers. Incident, first, second, third. First date, 8/42. Conclusion, how many batches are injected? June, we estimate about 550, about 550. Thank you very much and for your help. That's all.
All right, AV folks, y'all are being awesome. We're going to stay right on time. Thank you for your support. Next up, we have analyzing U.S. bills with automation. There's not a name on this. ChatGPT analyzing U.S. bills with automation. Is this like dollar bills or like legislative bills? Or I'm really curious. All right, well, go set up, introduce yourself, and what is your name actually? If you're going to sign up for Lightning Talks for Thursday, put your name down, or some Twitter handle or something, please.
Thank you. You'll find out momentarily why my name is not.
Just take your time. When you're ready, I'll start the time. And you can see what we see down here on the monitor.
Okay. My name is Ben Murray. I am a SOC lead at a finance company. So I was just having a conversation with a few original OGs from FIRST. This is my first. They encouraged me to do a lightning talk, and I told them I don't really have anything I could talk about. But I do. It's a project that I'm working on. Does it relate to cybersecurity? Possibly not. But I would just like to share it with you and have some really good conversations with everybody here. So the tool or the main problem that I saw and I wanted to address or find a way to solve is the U.S. Congressional bills, right? They're oftentimes extremely long and complex documents. And I think the latest budget debt ceiling bill or something like that was $300 or 300 pages. And a lot of times what will happen is these bills will get brought to committees and to be voted on with a very short amount of time, which leaves just general citizens kind of wanting to know, hey, can we get a copy of this text or can we read it? And often case that doesn't really happen, or it does happen, right? But some people don't care. And I think there's a significant, anyway. So the Patriot Act is another good example of this. The Patriot Act, right, 2001 or October 23rd. So the vast majority of the members in Congress admitted they didn't read this bill before it got shoved through, and then of course passed almost like immediately, right? So this is another issue. But another thing too is legal bills they're obfuscated with tons of legal jargon and stuff that I'm not going to pretend to know. So also the average American, these are statistics, I can pull them up where the source I got them from, but the average American has an 8th grade reading level. So there's that. So what was I trying to do, right? So the idea is that I created this bot, if you will, essentially. It's probably makes a lot more sense to a lot of the people in this room than everybody else. So on a daily basis, it goes and it'll scrape congress.gov's website. It looks for any new bills with a full text, not just a summary. And then what it does is it then passes that bill to ChatGPT for now until we can, my partner and I, train our own models, right? And then it'll summarize the entire text of the bill and then automatically post it to Twitter. As of this time right now, right, I got so caught up in trying to prepare for this presentation that I learned I was going to do yesterday that I broke it, so it doesn't work right now. So I'd love to show you a demo, but... Thanks.
Will be open source?
sorry, maybe. I know like the Department of Defense is around here somewhere, so if I don't come back, you guys know why. But the potential, so what this is going to do is when we get there, because right now we have like a tiny POC, right? So what this does is it brings transparency to bills. So it's going to deobfuscate the legal jargon, sheds light on the sort of gray areas of politics that get things like rammed through. And so we'll also tie in the politicians who sponsored the bill. It'll also grab any recent campaign donations that the politicians may have had. It'll also examine the Federal Registry for any midnight laws that are passed. It'll analyze the Congress speakers' speeches, so the House bill speeches, and then it'll generate alerts to anybody that signs up, and they'll get notified, hey, your so-and-so is represented in this district, is passing this bill, they're sponsored by this, and then it'll also allow us to track the political rhetoric between when lobbyists maybe donate a significant portion of money to a politician, and we can track the trends in the rhetoric. But it'll also directly correlate to those lobby donations. So if I'm not standing here next year, you know why. But I think that's pretty much really all I had. I mean, there's a lot to do right now that I'm still working on, but I would figure I would share it with you. There is I do have a Twitter for this, and I think I made an anonymous TikTok, and I got 2,000 followers in like one night, so I wasn't prepared for that. It's US Bill Analyzer on Twitter, so feel free to check it out. There's some examples of what it's doing right now, but they're old posts that I haven't updated, but I just want to say thank you for entertaining me. And
thank you so much.
Yeah.
Thanks. So that was US Bill's Analyzer on Twitter. That was actually pretty cool. I can think of a lot of other ways that I could use that in other domains. Thank you. That was, I think, spot on. Next up, we have Vinay to talk to us about some data science for threat detection. When you're ready.
Okay, I'm ready. Yeah, my name is Vinay, and my role is I'm the Chief Technology Officer for Cisco's CSIRT team. So what I want to quickly talk about today is our efforts towards how we have been leveraging data science, and one of my goals has been for our team, which consists of around 40 to 60 analysts globally, as well as 15 to 20 investigators, how I embed them in leveraging more data science as part of their job. So starting with the key takeaways, which I want to share here, right? So we have been kind of, I think with some of the talks which we saw today, right? Advancements in data science have come to that mark where security operations have to start leveraging it, right? So it's definitely there. So we have been trying to do that for a year and a half, right, and with some positive results. So it starts with building skills in a team and layering some foundational stuff, and I'll talk a little bit about that. And then as you do that, you should be looking for early wins. There is a lot of hype around AI/ML, so that's one of the things which you need to be doing to look at what are your early wins. So what are the challenges in SecOps which is leading us to do that? Increasing log volumes is kind of, I think all of us, every 12 to 24 months, log volumes are doubling. Keeping up with detection plays, right? We have around 700 detection plays which we run. And scaling those 700 plays, analysts spending that time, how we do that. Cloud is a big disruptor with ephemeral resources, IP addresses changing. Skill sets, right? Hiring good analyst investigators is hard. Analyst burnout, right? And how we can leverage data science, machine learning to help with all those. So this is kind of my quick, and I could kind of talk about it for an hour, and if you want to talk with me offline, I'm happy to talk about it. But it started with some skills development. I don't want to go and hire like 5 data scientists. I want to build skills inside. That means I have to change the mindset of analysts, where they are looking into regular expressions to some programming, sprinkling them with ability to write some programming. Building an environment, making them available instead is the simplest one to start with is Notebooks, Jupyter Hub, where they can start doing their analysis, give them some packages, as well as enabling some of the capabilities in the existing SOAR processes like SIM platforms and others. So these were some of the early successes for us, areas where we started looking into leveraging, right? Anomaly detection is definitely one of the biggest use case for security operations. Along with predictions, we all deal with attribution, missing attribution, how we can predict attribution based on some of the models. Time series trending, right? Visualization for analysts, like when we do in Splunk or in Kibana, we do visualization, how we can have the notebooks which can have a good visualization for analysts to take quick decisions. And even going back, like we saw the ChatGPT use cases where we can go back, take enriched information about 200 analysts who have already looked at that particular incident. Can I summarize that back for the analyst who's looking at the new one? And then one of our goal is to always reduce the false positive, right? Reduce the benign cases and focus on more true positive. Now, I'll quickly show you maybe some screenshots here, right? So this is one of the anomaly which is on AWS resource misuse. So again, like some of the speakers said, a lot of statistics here, right? I wouldn't have time to go into that. This is another one where we are using to look at some of the log flows, looking at flowing into our systems. Another one, right? This is actually taking an IP address, right, and try to predict, like, is that IP address belongs to us or from where it's coming, right, and what's the risk level, and going against a lot of different telemetries. One of the things which we realized as we did that, right, that our analysts, not all of them like to be developer. So we took a lot of these notebooks and also enabled it via the bot, right? So analysts who don't want to be coders, they can deploy their notebooks and make it available via the bot so that others can just run it, right? Again, talk with me offline if you want to learn more about this, right? So I'll just summarize it back, right? So this has been our experience for last 1.5 years. We've been leading this effort to make our analysts more knowledgeable about data science, how we use machine learning. But it's given where we are, it's becoming very important to build those skills, right? And we have some successes with that, right? And always we look into some of those early successes so that we can show and build confidence both from management as well as our own workforce on leveraging this technology. With that, thank you.
We'll see if we have time. I'd love to give you the slot. But we'll see, we'll see. So next up we have open source reporting on ransomware incidents in last year, 2022.
Okay, cool. Hi, guys. My name is Darrell Johnson. I'm from Silabreaker. So I want to talk about a white paper we did, and we just released very shortly. So we covered it on ransomware, and the idea with this was to look at the comparison between the initial attack, when a victim was hit, when it was published on a ransomware blog, then when the first public reporting of it started to come out, the victim's own disclosure of it, and then the victim is claimed by the ransomware actor. There was posts of the actual breach or even prior to it on a dark web forum. The idea was to figure out the importance of like self-conducted scalable monitoring and how to figure out if you have 150,000 vendors out there, how important are they to you? How quickly are you going to be told about it by your vendor? How quickly are you going to hear about it through public sources, dark web blogs, or open source reporting? So for the case of this, although there was about 6,000 different ransomware blog posts over 2022, we took 430 ones that were written in English, primarily focused on the US, North American markets, and Europe. So between the average time between those attacks and the disclosure of it was about 42.6 days. And then from that point on, when it became publicly reported, it was another 26.6 days. These are the kind of findings we were coming across inside there. Out of those groups and all the actors involved with it, we saw 5 in Alpha V were runner-ups, but realistically, Lockbit claimed 55 or 12.8% of all attacks out of the ones we analyzed. The biggest targets, non-surprisingly, were healthcare. Even though Lockbit does constantly claim that they do not target hospitals, they are constantly advertised up for sale. We see that data coming across all the time. After that was government, education, tech, and financial services, much further down the list. A lot of the reasons financial services were seen to be doing a lot less of this and being less affected because of more mature cyber threat intelligence programs and more programs that set up. And over 20% of all victims that we came across had a full data leak exposed. So notable findings were deep and dark web sites are the quickest indicator of a possible attack or breach. So the way we work, we're looking across everything out there on the blog, ransomware sites, dark web forum, an onion chat, whatever it might be, or Telegram, looking for first indicators of a possible breach, look for mentions of the company, their domains, their subdomains. So we try to cross-reference that with the hundreds of thousands of vendors that are used by any of our customers or that you guys will be using yourselves internally. Nearly every one of the top actors are using a ransomware as a service operation, right? So they are offering a RAS program out there, so whether or not they're doing it themselves or they're doing it on behalf of someone else and being fed targeted intelligence for them to do it, it's seen something that we come across quite regularly. I've already mentioned Lockbit, they still go after hospitals no matter what they say, but Conti's campaign in early 22 led to Costa Rica declaring a national emergency. So they disbanded shortly after that. Now we see them regrouping and forming up in a different way. But I think it's quite impressive the scale of the impact that they had there when that happened. 2.3% of the study group were only publicly admitted to paying a ransom. We know realistically from our sources in the intelligence community that's much closer to 18%. But the ones actually publicly announcing it are 2.3%. That was probably being affected, and that number will be a bit lower now with new legislation brought in the United States and everywhere else about actually being able to pay a threat actor. Between Vice Society and Lockbit, 29 of the 430 organizations had a full data leak. Victims appear to be given just over a week after the attack before it being added to a leak site. But the higher the volume of the attack, the higher price they're looking for, and the quicker they actually get a response and negotiations start with the organization that's being impacted, the quicker they are putting and starting to post data online. So 23% almost never publicly addressed their incidents. 14% disclosed the attack on the same day it was known. 40% took a week and 3 months to disclose, and 189 of these 430 were actually publicly posted to the blog sites. 6,000 victims we were seeing on the dark web, so only 442 in this study. Wider risk to supply chain are now taken into consideration, especially when you're looking at your attack surface. From a large organization standpoint, we need to be aware of the possible threats coming through. And so what we find is live monitoring, whether you do it through a tool like ours or your own, pulling in feeds, pulling in onion sites, pulling in ransomware blogs is a key part to doing it, as well as working with your third-party risk management profile, finding a way to pull from their program and data sets to lively update the new vendors you've onboarded and any assets attributed to them. And then that way you can trigger that in to look and discover a new attribution or new disclosures or leaks that might be affecting your supply chain. And then quickly reporting on it. The way we do it, and I've just gone off here, I'm going to do it real quick. So if we take ransomware blogs, oh my gosh, there. So we would normally take inside any of these ransomware blogs in real time. Oh, of course, not opening. So the idea, we'll take all of the data in real time from there, track across all of the different vendors, hundreds of thousands you have, all the domains, all the nicknames through, and then cross-reference that out now. But if you guys want to see the full report, it's about 16 pages. I have some physical copies here, but you can quickly go on to here. There's a QR code there, our details and contact information. Feel free to download it. And if you want to have a chat about anything, please let us know. But thank you so much for your time. Good time.
All right, next up, we're going to try to cram in one, maybe two more, and then we're going to wrap and have a BOF about standards. Maturing abuse notifications. Brian, come on up. Another no slides. Look, I admire your courage. You're a man after my own heart.
See how this goes. All right, good evening. I am Brian DeWingart. I work for CISA in the US. So formerly known as US CERT. So as a national CERT, we have some problems that I'm hoping that we can have a discussion after this. So we take in and see abuse notifications for all of the United States. And when we see these things, likely when they come through, they have no evidence. And so if a country CERT comes to us and says, hey, we've seen abuse, we have a problem, how do I go to an ISP or a telco or a hosting provider and say, you have to do something, it's just a complaint. Now, as someone who worked at a SOC for a global telecom who ran the abuse desk, I ignored those when they came in because I had no evidence to go on, and likely I had other things to do. So what I'm proposing is to mature this space and say, and develop some norms to say, if you're going to do abuse notifications, you provide some evidence. And we define standards of what that looks like and shape it. And I think there's some other work being done about how we could wrap this into sticks or MISP to include automation in this and make it easier for folks who have logs to just snip it in and pass it on. Anyway, that's literally my talk. It's just a proposal for some ideas, and I'm hoping there are questions. So anyway, yeah.
So, in the mode of encouraging some questions, yes, clapping is encouraged, but like this is a dialogue, and you've got like 4 minutes left. So, you're talking about like what would be useful for us, your house, in a standardized definition of abuse notifications. So, anybody else ever had the idea, if only abuse notifications were a bit more standardized, that would be great. Get to a mic, tell us what you think, right?
Yep, that's it. And again, if you don't want to talk here, you want to talk afterwards, happy to do it.
Because we're having a standards BOF after this. And questions? I feel like wrapping in a minute deserves applause. Go!
Sorry, it's me again. So comment, not a question, but a comment. I think there has been some really good work on measuring the impact of abuse notifications and how they're written, how long they are, how short they are, what they contain, etc. So any standard, I think, should look at that and then adapt the way we address folks for abuse notifications based on these findings. Then they're more effective.
Okay, thanks. Appreciate it. All right. Well, if there are no other takers, I'll just.
How can folks reach you if they want to continue the conversation afterward?
Yes, I'm here all week, and if you want a business card, I would say my email is pretty long, so that's probably the best way to get a hold of me.
Well, thank you so much. Let's have a warm round of applause there. All right, coming up next, and I think we're going to wrap here, is, wow, we made some time up, though. So be sure, if you've had some ideas today, tomorrow, or even Thursday, go sign up for the Thursday round. David Bizul, SOC Platform for CERT. Come on up, David.
I'm David Bizol from France. So. Thank you for the slides. Where is the remote?
Oh, okay. Hang on. This doesn't count. It's right there.
So, I'm David Bizol. I work in a company named Sequoia.io. We provide a SOC platform fueled with threat intelligence. So if you want to have detail about that, I invite you to check our blog.sequoia.io. But anyway, even if our solution is mostly made for SOC teams, some of our customers doing incident response in their activities told us it was especially interesting for 2 different incident response scope for hunting activities and for monitoring during containment and remediation. So to make it short, we have 2 slides and they are quite similar. For the first one, for hunting activities, you can ingest a massive amount of logs, mostly code logs because they are from the past, the attacks has already occurred, and to check if something in these logs can be matched with something that we know coming from our threat intelligence environment. So instead of doing classical log forensics, this can outline very rapidly to understand why or how an incident occurred. And on the other side, for, let's say, monitoring activities, especially for containment and remediation, the process is almost the same, but you can deploy our agent in your victim environment or deploy our container, our log concentrator directly on a Docker container. So it goes quite fast, and it will allow you to verify if the incident you're working on is contained effectively and there is no further attack going on. So that being said, even if it's a commercial solution, we recently decided to offer these capabilities for free for CERT teams as long as they work closely with the SOC MSSP. So if you're interested to discuss about that, I'm here during the next day. So feel free to contact me or discuss during break sessions. Thank you.